All right, so in this video, what we want to do is we want to complete the square. Say it. Okay, now we're solving a quadratic equation that's in standard form. Here's standard form, right? This is the quadratic equation in what? Standard form. When a quadratic equation is in standard form, which means I have an x squared, an x, and then a constant here, there are 4 ways to solve a quadratic equation in standard form. You can do it by graphing. You can do it by factoring. And the third way is complete the square. Now, all 4 of these ways will get you the same answer. Okay? But let's learn complete the square in this video. Okay? So here's our problem. X squared minus 16x plus 15 equals 0. Here's our problem right here. Okay? So step 1 is to get C on the right side. Say it. C on the right side. So to get C on the right side, what I'm going to do is I'm going to subtract 15 on both sides. Say it. Now you can see right here where positive 15 was, it's not there anymore, is it? But I'm still going to leave a space there. So I'm going to write this as x squared minus 16x, I'm going to leave a space where the 15 was, equals negative 15, and then I'm going to put a space after it as well. Okay? Now you need to fill both of those spaces. So you need to add something to both sides. Well, what we add to both sides is b over 2 squared. Say it. B over 2 squared. Okay, so b in this case is negative 16, isn't it? Isn't it? So b is negative 16 over 2, which is negative 8, and then we square it. What's negative 8 squared? 64. So what we're adding to both sides is 64. We added it to the left, but you can't just add something to the left. You also have to add it to the right. So we'll add it to the right. So now I have added 64 to both sides. Now here's what you did. Right here, you completed the square. Say it. And what that means is you made this into a perfect square trinomial. So when it factors, both binomials will be the same. It'll be like x plus 2 times x plus 2. Or x minus 4 times x minus 4. Both binomials will be the same when you factor it. So let's factor it. So I write 2 binomials. I'm factoring the left side. And it equals whatever negative 15 plus 64 is, which is 49. Okay? So what times what is x squared? X times x. And what times what is 64, but where the numbers are the same? 8 times 8, right? But in this case, we also need it to add up to be negative 16, don't we? So it's going to have to be good. Negative 8 and negative 8. When you are completing the square, when you factor, both these binomials will always be the same. That's why it's called completing the square, because when you factor it, you have a perfect square. Okay? Now, tell me this. Let me zoom out real quick. Tell me this. What is 3 times 3 the same as? It's the same as 3 squared, isn't it? Isn't 3 times 3 the same as 3 squared? And so when you look at this problem right here, what is x minus 8 times x minus 8 the same as? X minus 8 all squared, and that equals 49. Well, now we're back to solving quadratics by taking the square root, aren't we? Look, now I only just have one x, and I'm trying to get rid of this squared. So what do I do to solve this? Square root of both sides, because that will get rid of this squared. Square root both sides. And so you have x minus 8 equals, what's the square root of 49? 7, but it's not just 7. So I need to write another equation. X minus 8 also equals negative 7. And that's how you get 2 answers. The square root of 49 is 2 answers. So I'm going to add 8 on both sides here. And so I have x equals 15. And I'm going to add 8 on both sides here. And so x equals positive 1. And so there are your 2 solutions. If I plug 15 in for x here and here, all this will equal 0. If I plug 1 in for x here and here, all of it will equal 0 on the left side. Okay, so we solved it. If I were to graph this function, where would the graph touch the x-axis? At 15 and 1. So if we were to graph it, real quick, over here at 15, you'd have a point, and right here at 1, you'd have a point. So you know you can kind of just go ahead and do a little sketch, can't you? You know your graph would look like this, where it touches the x-axis at 1 and at 15, doesn't it?